Welcome back to BSA by Design, a podcast about transforming healthcare, educational, and research facilities through expert design and insight. I'm your host, Brian Moore, and in this episode, we're going to take a look at some of the common pain points in design around the integration of medical equipment and some of the solutions a couple of our architectural leads have insights on. Our guests on this episode are Matt Amore and Joe Sagan. Matt Amore is a senior architect and architectural lead for BSA in our Indianapolis studio. Matt earned his Bachelor of Science in Architecture as well as his Master's in Architecture from Ball State University. He's a member of AIA and NCARB licensed. He previously worked for Cripe before joining BSA in 2022. Joe Sagan is also a senior architect and an architectural lead at BSA for our Indianapolis studio. Joe earned his Bachelor of Science in Architecture and his Master's from the University of Illinois at Urbana-Champaign. He is NCARB licensed and has been with BSA for over 10 years.
I always like to start off with first-time guests. Can you share a little bit with me your passion for architecture, where it came from, how you got into this profession?
I'll start from my standpoint. I kind of fell into architecture as a kid. I liked drawing a lot. I remember laying on the floor with these big pads of paper, and I would draw like cartoons and stuff like that. And I like building Legos, kind of like I think every architect.
This is like the third or fourth.
Yeah, every architect says that. But I love doing that. In school, I actually thought I was going to get into music, and my parents, kind of told me, don't do that. So architecture was kind of the next step. But I think like a lot of 17, 18-year-olds, when you go to college, you don't really know what it is until you get into it.
Right.
And then it's a different world once you kind of get into that profession. I can't imagine myself doing anything else. It's
now that you've been doing it for so long, right?
Exactly. Yeah, so long. Trainer says that. But it's about helping people, and it's about solving just different problems constantly every day. I think that's kind of why I do it.
Yeah. Really quick. My daughter is a freshman at Purdue, and she thought she had her major, right? And then she got to semester break and was like, I don't think I want to do this anymore after doing some of the entry-level stuff for it. So when you took it, it was the opposite. You're like, oh, I like this.
Yeah, and I had gotten into it. I knew that's kind of what I wanted to go into, but, that kind of, late junior, senior year in school, but it's sticking with it, I think, is more the testament, I think, to a lot of architects in school than kind of getting out of it, I guess.
Sure.
Yeah.
Joe, how about you?
So probably growing up, I have all the same cliches, and I like to draw. I was kind of good at math. I enjoyed playing with Legos, which I still do, by the way.
Yeah.
Still enjoy Legos. But I guess as I left high school and went to college, I really knew that I did enjoy architecture. We spend so much of our time in buildings, for better or worse. That's just what we do.
Right.
And to be able to have an impact on that is pretty amazing. And as I went through school and the more we did architecture, the more I'd find you walk into a building and, I look up at the ceiling or around it stuff. I don't really care what's happening in the building. I want to know what the building looks like and then question why everybody did what they did. So, yeah, I've really enjoyed it the whole time. And now being far enough out of school, I still enjoy it.
Do you guys ever pass buildings that you've worked on? And
Oh, yeah.
Yep.
Nudge your wife.
Yeah. But you joke about going into buildings and looking at. My wife hates traveling with me. Like we went to New York.
Oh no,
many years ago, and I ran her ragged, I think, going around the city. But we walked into, I think it was the Ellis Island, the main building there.
Right.
And I'm just walking around like this, and she goes, "You're next going to hurt this trip." And I said, "Yeah, probably. It'll be fine." But yeah, no, just checking it all.
Yep. I got lucky since my wife does the same thing.
Yeah.
So we both look up.
Oh, that's good.
You guys know, but
you guys can have conversations about it.
Yeah, and we can complain about what everybody did.
Yeah, how you would have done it better, right? Yeah. Well, thanks for coming on again. I know this is a really specific topic around medical equipment integration. Can you share with our audience some of your experience with the healthcare market and the projects that you've worked on? And if you need to state there's a confidential client or something like that, I totally get it. That's fine as well. But this time, Jill, let's start with you.
So in my time at BSA, I've primarily worked in our healing market. So done almost all healthcare, couple of little discovery projects here and there. But overall, I've worked on several different projects with several different clients, mainly in Illinois and Indiana. So over in Illinois, SSM, And then here in Indiana, a lot of IU Health stuff that I've worked on. All these projects have had a range of scale from very, very large inpatient units to some vertical expansions down to just, one room equipment replacements, actually.
I've worked on a range of projects like Joe, done everything from some small outpatient clinics to I'm working on with Joe with a couple IU Health projects. I've actually done 2 academic medical centers with them. So I've worked on the inpatient build side, but also kind of more procedural equipment, large, heavy procedural spaces.
We're hearing more about academic medical centers. What are some of the differences between strictly like healthcare and an academic medical center?
Basically, there's a teaching component,
right?
And what you're seeing a lot is handoff between either schools of medicine and the local areas. I think you're seeing that meshed a lot more than you had typically seen. You get areas where it's strictly small rural medical centers and things like that, but a lot of these big urban areas have these academic medical centers where there's a lot heavier of a tie between the local school of medicine or something like that.
Really boils down to space in that instance. Since you get the students in there too, there's a space aspect to that.
Yep, more teaching spaces, more conference spaces, things like that.
Joe, can you give me an overview of why medical equipment integration is so crucial in healthcare design?
It's when we think of design, typically everybody always thinks about the volume of the space, what it looks like, the finishes in there. And you tend to overlook the pieces that everybody touches day in, day out. I mean, that's really, for the end user, what has the most impact. And in hospitals, a lot of that is the medical equipment, which can range in a variety of sizes from, the glove box on the wall to MRIs and CTs and booms in OR rooms. So I think there's an important aspect of getting that right during design and making sure that placement can allow the staff to do their jobs to the best of their ability and really enhance what they do and enhance the patient's view of the hospital.
Because you've got, large pieces, small pieces, and if you're not planning for them right, somebody's turning a corner, running into something maybe, right?
And it's funny because I think it's always the small pieces that get the most complaints. If that glove box is on the wrong wall, that's all anybody will ever complain about for the entire time that hospital is open, is that glove box is not in the right spot, which is the easiest thing to fix.
And you're even seeing in small instances where there's rail systems actually, I can move this hand sanitizer, this glove dispenser, all that, like within inches on a wall, as opposed to, traditional, it screws directly to the wall and that's where it is. There's systems now to actually allow flexibility on rail systems and everything to help move that, but it just kind of depends on what the owner ultimately chooses.
Matt, let's talk about the early planning challenges, some of these things that we just started talking about. Specifically, when should equipment planning start in the design process?
I've thought about this a little bit, and I'm going to say that earlier the better, but with kind of a caveat. And so with large-scale projects, I'll call it new builds, those timelines can last a really long time. So you may not get into a purchasing agreement until
I was going to say, you got to know what you're dealing with, right, before you can plan for it.
Exactly. So that's why I say that earlier the better. And it's really from the design side, it's the general understanding of the types of procedures that are going to occur, because the equipment allows specific types of procedures from the medical side, and a specific procedure can kick in a bunch of additional requirements from the healthcare side, whether it's, I'll call it a level of invasiveness, so class 2 to class 3, that type of thing. Okay. It can actually domino additional HVAC requirements. It can domino additional infection prevention requirements, so that type of thing. You have to have an idea of what they're actually going to do and what the equipment's capable of well in advance of them actually being able to purchase it. And sometimes that still changes. So kind of the biggest thing that the design team has to do is allow for flexibility with that equipment, either with the quote unquote 4 walls within the space. Are you allowing enough space? Are you allowing enough ceiling height? That gets into early structural considerations of how much floor to floor are you allowing? How spread out is the column base? So it's, when I say that earlier the better, it's really allowing, are you allowing enough room in the space to be able to do the types of things? And all of that gets into really kind of early budgetary concerns. So it's kind of a balancing act through the whole process.
Yeah, a lot of chicken or egg conversations, it feels like.
Very much so, yes.
And I'm even thinking of the advancement, like to your point, some of these larger projects that could last several years, if not half a decade or longer, right? When I'm trying to think of new advancements in technology, different systems, like even in your home, right? You're building a house and you pick a refrigerator. Well, if it's lasting 5 years, they're not getting the newest model, right? Because you've had to plan for it in advance. Or to your point, sometimes are they flipping those out after construction has started?
A lot of times that's the case, is they're waiting until the last possible moment to where, when do I actually need to install this? And I'm getting the latest models. A fair amount of that is flexibility with software on the equipment side.
Okay.
It's a giant computer, but there's still instances where what that machine's capable of doing is completely different than what you had planned to run originally. I've kind of been living that with the current project I'm on for the past couple of years. Is there's been a lot of equipment changes. We're still flexible and still learning what we're able to do, but it's still a little bit of, you're test fitting it constantly, and it like I said, it's test fitting it through walls, through the ceiling, through what infrastructure you're providing, what infrastructure is above and below it. It can be a complicated piece of machinery. Sometimes, all the equipment moves. So that's the other thing. What are you allowing for? If it moves on the floor, that's a different animal because you've got to provide space for it structurally. But going back to allowing the flexibility of the equipment is probably the biggest thing that you can do from a design standpoint.
When it's happening later in the process, what are some of those common issues there? And I'm assuming, obviously, you've talked about it, budget, timeline, there's spatial considerations as well?
Yeah, there's spatial considerations. There's structural and utility changes. Joe talked early on, I think, about and I'm strictly speaking large medical equipment.
Yeah.
The smaller stuff is a little bit always
Like the glove box?
Yeah, right. That's a little bit different of an animal, but
It's like a domino effect, though.
because that large equipment affects where you put small stuff.
Yeah.
But what you run into with equipment replacements, does the current building allow for that equipment to be replaced? Both structural and utility changes. There's lots of vendors get involved, so coordination between those parties is really paramount, and sometimes the vendors change. You could be working with one equipment vendor for this piece of equipment, and then it changes later on. So they may switch vendors from that standpoint. So are you allowing that coordination to occur? You want it to be vendor agnostic. What can you do to affect adjacent areas? So, if you don't allow, if a piece of equipment has an additional equipment room requirement, that affects not just, again, everything within the four walls, it can affect adjacent spaces as well.
We kind of touched on it through the conversation, and the real interesting part is it's the smaller and more mobile pieces, which have much less of an impact on like the big spatial considerations and the big infrastructure considerations are the ones that get picked early on, and we know what they are, we know how to place them, we know their size. It's the big pieces that always tend to want to get delayed, and a lot of that's just wanting to get the newest and best piece in your project. I think it's kind of interesting that there's that kind of opposite. We need the bigger stuff earlier. We could do with the smaller stuff later, but we actually get it flipped during design. And I think as we've worked through these, and I know I've done a few and Matt's done a whole bunch, we learn each individually. We learn the mistakes that we may have made in the past or the lessons learned.
Sure.
So we can take those to the next time and the next time and the next time. And I think that helps kind of, as we do more, alleviate some of those kind of concerns of budgetary or timeline or constraints. And it's how we build in that flexibility overall.
Yeah, it's funny because, you have a general, once you've done these enough, you have a general understanding of what utilities are needed in the room, roughly where, but then they go and change the piece of equipment. It can change all kinds of stuff too. There's that building of knowledge as you work through these, and you get smarter a little bit every time.
Is there, with existing buildings, so not a new build, and you're going in to replace equipment that may be old, what's that look like? I mean, have you ever walked in there and been like, we don't have enough space, we don't have enough outlets to plug things into?
There's a lot of conversations both with the owners or the clients and then the vendors of the equipment. There's those tough conversations of, well, you want to do this, but
here's your limitations.
I don't know if we can, whether that's the equipment or updated codes or guidelines for healthcare. But we do have, as we've worked through so many projects, we kind of get some relationships with vendors, and we're able to call, and we may know where they're going to come out and say, no, you can't do this, but that's not really the case. We have a little bit of flexibility here. Can you work with us to get this in there?
And it's funny, you talk about special considerations. I know BSA's done some projects where we've actually talked about like wavelength interference and how close a piece of equipment is. So it may not even be a physical space characteristic.
Yeah.
It actually may be what's actually happening within the air and radio waves and things like that that cause conflicts that you have to work through. So then we've had a lot of really smart people work on these projects for a long time to be able to talk through and kind of help solve those challenges.
Let's talk a little bit about infrastructure requirements, as there's probably some critical needs for modern medical equipment.
Power of the equipment, that's always just kind of a given. Everything needs power. A lot of these pieces of equipment may give off a lot of heat or require the rooms to be at specific temperatures or humidity. So HVAC is always a big component of that too. Those two are probably the easiest of them to deal with because we just know they're going to be there. Matt touched on it a little bit earlier. Structure. A lot of these major pieces are very, very heavy. So can the structure hold it where we want to put it? Yeah. Not only that, do you have a path to get it there? So it's really easy to beef up right under where that equipment's going to sit, but you still got to roll this thing down a hallway and get it into the building. So
it's like buying a couch in your house and then being like, well, wait, how do we get it inside the house? It's too big for the front door.
What door are you taking off to be able to get it in?
Right.
Yeah. We have to run through that whole sequencing process with the groups, with the construction groups. How would you get this in the building and where? And that's all planned ahead of time.
Yeah, that makes a lot of sense.
These things don't box up as easy as a couch. You take it back either. So
right.
The last one is our world changes. And, Brian, I've heard you talk about AI in the past. Everything is about data. So the newer pieces of equipment have more data requirements. They require larger data rooms outside of the rooms. I mean, just everything is about data. And I think that's just going to continue as we move forward.
And this is a really novice question, right? But you have multiple spots where there's those data hubs, or is there one central place? Or
yes.
So we've depends on the size, I'm sure, of the building and everything that's going on.
And what you really kind of don't realize is going into it is that every group kind of needs their own data. So you could have the piece of major medical equipment that needs its own data location. You can have the medical equipment booms that need its own data location. You can have the, other third-party vendors that need data. And sometimes that's all aggregated to one, but you get into weird conditions of cable length and how often, how long is that cable to be able to transmit the data in an appropriate amount of time. So sometimes it's in an all-enclosed space together. A lot of times it's really satellite locations. Sometimes it's in a hallway outside the room based off of what the owner wants to do. So it can be all three of those things, basically.
If you've heard me talk about this, I'm always kind of with an eye to the future, right? How do you future-proof for technology advancements when it's coming to infrastructure?
The biggest thing that I've found is it's important to allow space for different groups. That can be as simple as, do you have general space underneath the floor to be able to connect equipment from one room to the other? A lot of times this equipment is either floor or it's ceiling mounted. So there's an infrastructure requirement above and below, kind of, I'll call it the space that you have to accommodate and the connection points to those. Sometimes that can move, and placing that center of equipment is extremely, extremely important. Again, we talked about sometimes this equipment's picked, a year later after a piece of floor is already in. Trying to be a soothsayer a little bit and seeing and trying to figure out where that's going to go. And it's going to go in this roughly 4x4 spot. Let's give ourselves the most flexibility to put what we need to put there. But allowing for, that's kind of structure related, but allowing for future flexibility with everything that's kind of in the ceiling and around on the wall. We've been currently working with some all-in-one vendor solutions that actually have a all-in-one laminar flow system. So laminar flow is where you provide enough clean air above the patient to not allow infection. But you would have all of that system and the boom supports, and all of that is actually flexible based off kind of a ceiling hung system. And we've actually been working with some groups through design through this process as kind of a third party that our contracting partners have brought on board. And it's specifically allowed or designed to allow flexibility for future equipment changes, which will happen throughout the life of the hospital.
So that's interesting. the more times you've done it, right, you start to have some of that, you called it soothsayer.
Yeah.
And like you got this little magical ball, not quite an 8 ball, but like you're looking into
Sometimes
it. Like, I can see into the future. This is what's going to happen. Are there any common oversights? And I know we've talked about a few. Sometimes the smaller stuff can get overlooked, but other things that might get forgotten along the way?
Really, I think it's everything outside that specific room. I think it's a lot easier to get everything coordinated within a specific room, but it's the little things that trip you up, like when you got to run a cable under that floor to the next room, and it's like, oh, well, what's above ceiling below me? And you got to go and explore that and look for it and understand where your challenges are.
You've got to take a look at the entire stack then, right? Yeah.
Or things on the other side of the wall, because sometimes you can't put something in the wall like you wanted to because there's something on the other side or there's a pipe running down that.
Right.
It's that little stuff.
Don't want to drill into that either, right?
But one of the biggest ones is how do you get it into the building? There's a lot of planning that goes into that. It can even get into the site work. Sometimes the civil engineers or the landscape architects have to deal with it being, these pieces are heavy. If you need a crane out there to pick it up, you got to provide a spot for that crane to park and be able to get that piece in there. Actually, in a user group I had just a little while ago, it's not quite medical equipment, but it's the same type of a conversation. We were doing a helipad, and one of the users goes, well, what happens when the rotor breaks? How do we get the helicopter rotor up to the helipad? And we're all just sitting there like, that's a thing?
Yeah, that's a thing. You could break it. Yeah.
So we went through, they're like, well, obviously it won't fit in the elevator. We're like, well, maybe we can ride it on top of the elevator cab to get it up there. Ultimately, it worked out that we used the window washing equipment. But
oh, there you go. Yeah.
I feel like there's always that one question, and a lot of times it's how do you get it there? That gets you. So
I would have never thought the window washing equipment. That's a pretty good solution too. Matt, do you have anything now?
One thing that I think we found is, you talked about data, as silly as it sounds, cable management and space for mobile and third-party vendor equipment. So there's stuff that, like, we joke about having the magic cable. There's stuff that we can't foresee that they're ever going to put in this room. We don't know. So are you allowing enough future flexibility to something else can fit on this desk that we've not planned for? Or where do all these cables go? We've
I'm picturing like Christmas Vacation, and like all these cables are all wrapped up together.
You'd be kind of horrified or probably surprised in some of the things. But we've talked about, where does all this sit? And we've kind of joked internally about hospitals are turning into data centers where they heal people at certain points, but there's just so much stuff and so many cables. How do you manage all that? And where does all this stuff actually connect? We're not at wireless power. We're not at wireless. You really don't want wireless transmission in a hospital because if Wi-Fi goes down, that causes issues. Yeah. So you still have to deal with a physical cable plugged in from point A to point B. Yeah. Where does that live? Anybody that sits at a desk, if you're kicking cables, you're kicking cables or there's stuff up there, that makes for a not great work environment for somebody that's trying to save a life. So how do you eliminate that as best as possible? And again, multiple connection points to the equipment. Where does all that stuff go? Are you allowing space for it? Or are you allowing it, like Joe talked about, above and below? Do you have a plan there? And there's, are you allowing for points on the wall? There could be a camera here that you have to plan for future. So it's all that stuff that you don't really think about. That's not the main piece of equipment in the room. It's all that ancillary stuff that you have to kind of think about.
Coordination on medical equipment has to be a complex thing. As you guys are explaining, there's way more than I ever thought there would be. How do you navigate those vendor requirements as you design spaces for the equipment?
The biggest thing is really kind of developing a good relationship with those people. There's big players and there's small players in that regard, but and those guys are used to working with across the country. They're used to working with a lot of design team members. They're really good partners in terms of being able to explain their system and work within the requirements there, but just developing a good relationship with them and say, hey, it says I need 2 feet here. Can I get away with 1'9"? And they go, yeah, we can do that. Or no, we can't do that. And so it's developing that dialogue and that conversation between them. They have early planning guides, but those change from piece of equipment to piece of equipment. You start with those and understand what your kind of limitations are. And then you kind of have those conversations to talk through them and say, can we do this? If they buy this, or if they don't buy this part of it, that we talk about. And I'm speaking more from the major medical equipment. There's options galore. Like think about buying your car. It's
Right.
every gadget widget as part of
Right.
it can be added on or subtracted, and those have additional space requirements. So what you have to start to nail that down the further you get along. It's making sure you're not boxing yourself in from that standpoint. I think I kind of hit it into the ground a little bit, is allowing for flexibility is the best thing you can do.
Were there challenges related to interdisciplinary needs or managing stakeholder needs? I'm thinking, some of these larger places, you've got cancer care, any number of different disciplines that you're trying to service. So what goes with that?
I guess challenges there's probably two ways to look at interdisciplinary challenges.
Okay.
There's the first way is more on the design team side, and kind of our interdisciplinary challenges with our favorite engineers on the project. They always want the information at the very beginning. They want it early so that they can design their systems. I totally understand it. As we've talked about throughout this, owners like to hold off picking this equipment, which usually holds off site-specific drawings. So there's always that challenge there of walking that line of how do we get both parties what they want.
Right.
I think that just kind of takes time, and you learn what we can kind of plan on and what we can't as we go through the process. The vendor installation guides that Matt mentioned can be a big help of getting stuff placed early on and kind of allowing us to move forward with the design while giving the owner the opportunity to hold off picking the final piece of equipment. And then the other side would be the hospital's interdisciplinary side, because we sit in a lot of user group meetings, and it's not just the doctors or the nurses that are there. A lot of times you'll get somebody from EVS or you'll get somebody from facilities, and everybody kind of has this push and pull of what they want.
Right.
And our job as the architect sitting in the room running this meeting is to make everybody as happy as possible.
So you're just listening to all that and trying.
Yeah.
I mean, it's like when we designed our office space, right?
Yeah.
I mean, it's the same thing.
Our office space may have been worse.
A lot more opinions, right?
I always go into these meetings and I always like to kind of say, this isn't really a presentation, it's a dialogue. I want to talk. I'd actually be happy sitting there listening more than actually talking, because that, it's my job to take all these different puzzle pieces that they're laying out there, their wants, their needs, compare those to all the references that we have that they care about, but they're not in the weeds on code and facility guidelines and all of that, and put that together and get them the best possible product.
Well, and that's following our innovation framework too, right?
Yeah.
Listening and listening, and then listening some more to try to get the solution ready.
Yeah, and being, going into those meetings, being prepared for the inevitable ultimate curveball. I've been in a meeting where the user group came in and said, well, what if we change where the patient head goes in this room? And that flips everything related to the room. And they asked that, what would that look like? And you have to really you're on the spot in that regard and trying to sit there and give them something to look at in a meeting where they can respond. That was probably that was one of the more stressful ones. Well, it's like,
I think I just it would be like it is, except flipped.
Just turn your head the other
Direction.
So, and it's being confident enough in your abilities and your team's abilities to sit there and go, this is what it would be, and trying to explain that to users that aren't, frankly, used to looking at plans. That's the other thing.
Oh.
These are doctors and nurses, and they think completely differently. And architects have a specific way of thinking that I don't think we acknowledge all the time. Is we take for granted that everybody can look at this stuff and understand it, and that's not the case a lot. Being able to talk through those challenges, and like Joe said, with all those stakeholders is really important, and distilling it down to something that they can understand. And sometimes they still want to see a picture of it. It just doesn't really, it's being able to show all that stuff.
That flexibility is important, Matt, in the meetings, to be put on the spot and be able to do it. I think it's always one of the hard lessons to learn. It's also okay to say, hey, I need to go look at this a little bit more. We'll get back to you. We want to make sure we're giving you the right information.
Are there any examples you can share related to success stories or innovative approaches to integration? Any kind of overall lessons learned, I would say? I
don't know if I'd necessarily say it's an innovation, but I've done the last few projects, and this is more of a patient room, so less of the CT or the MRI, but the patient room has a fair amount of medical equipment in it.
Oh, yeah.
Being able to design in a full-scale mock-up is a real great way to do it. You get a lot of users in the room. A lot of times they'll bring in current beds, current carts, current everything. They can run scenarios. They can they can get a patient off the bed and walk.
This is different than like the cardboard cities that I've heard a little bit about.
It's the same as the cardboard city. So the cardboard city really is meant for the whole unit, which that takes a ton of space. But it's a lot of times easier to get enough space for one room. But I think being able to design there, you get a lot quicker buy-off from users. They get a better understanding of how the space will work, including all of the equipment inside of it.
Yeah, so I think users see differently. They're, seeing something on a drawing is very different than seeing it kind of in person. And so we've been in mock-ups where they take stuff is actually Velcro or stuck in terms of gas placements on a head wall. That where that stuff ends up is it has a big effect on clinical workflow. So it's not thought of as medical equipment, but it is medical equipment because of it's where does this stuff sit, and they're able to actually sit there and pick up a piece, move a gas from here to here, and talk through those types of things, or move the cart from this side to this side, or move a computer a little further away, or I don't like this table that we're going to buy. It doesn't allow enough flexibility. So them being able to see that stuff,
visualization
is a big deal, and actually use what's planned on being purchased.
And those moving the gases, sometimes they can get infuriating when you're standing in the room and they go, we just need to nudge this over like an inch. And you're like, well, what does an inch mean? But then they bring out the canister, they bring out how would they connect, and you try to actually sit there and hold it with something next to it, and all of a sudden it's like, it clicks and it's like, I understand this now. And just that extra saving them a couple seconds of connecting a tube or taking in and out a slide can be really meaningful to the end users.
And kind of going back to that third-party vendor flexibility, we talked about that all-in-one laminar flow system that we're kind of working through is being able to put that system's designed to be, I can put a boom here. I've also allowed for future flexibility to put a boom over here that we may not use, but we've got the flexibility to be able to do it. And it's giving them, a dual arm versus a tandem arm. Think about the tools that you use every day. This is the tools that those nurses and those doctors use every day. If they're not functioning how they're supposed to, you get really frustrated. And that just gives that level of client satisfaction, that level of care that doctor's able to provide is much better if they're happier in the space and giving.
Oh, of course. You don't want them thinking of that stuff. Right?
Correct.
It should not even be in their frame of reference.
Correct.
Let's pivot a little bit and talk about everybody's favorite topic, cost management. Matt, how do you balance equipment needs with budget constraints? And you started touching on it a little bit earlier, but
you really have to guide the owner through that process, and allowing for future flexibility can help. So if you don't allow that flexibility, it's more expensive to put it in later or flip it out later. So the thing most people don't think about is the rate of change with this equipment, and it's really complicated, and a lot of it's really kind of hard pointed, but it evolves so quickly that changes out way more than you would ever think it would. So you have to work to not lock in future planning. So it's kind of the basis where I think we have the most effective. Do you allow them to do something in the future, or are you hurting future development and future flexibility? Because sometimes this equipment changes every 7 years, and you're talking millions of dollars in terms of an MRI replacement or something like that. Because this stuff isn't like as cheap as a couch bringing it in, anything like that. But it changes because that technology just evolved so rapidly, and it's getting faster and faster. So how do you allow for that medical equipment change out, which is going to happen? So that's the biggest thing.
You answered one of the questions I was going to have, which is what time frames are we looking at for some of these pieces?
Sometimes,
like you said, an MRI could be 7 years.
It could be longer than that. It can be shorter than that. It just kind of depends on the specific piece of equipment.
Joe, are there some value engineering strategies around cost management?
When you get to the major medical equipment pieces, I think we want to do what's best for our client and let them get the newest and greatest things. So a lot of times there's not VE when it comes to the equipment itself. It kind of goes back to, okay, what's the flooring in the room? Is how much wall protection is there?
Don't touch the equipment.
Let's look at everything else around it. So for the major stuff, a lot of times it comes back down to us and the interiors team and figuring out ways that we can help them get to the budget number they need. When you get to the smaller stuff, such as the glove boxes or sharps or the carts, the first thing is there anything that they can reuse? A lot of times they'll go through, our owners or clients will go through a whole facility management, and they'll look at what they have, what they can reuse, what's at the end of the life.
I always like to hear about what's next. So let's look at some future trends. Are there Any emerging technologies affecting design around equipment? Any innovations that you've seen or heard of around equipment integration?
Yeah, we've talked about kind of those all-in-one laminar flow systems that can create, basically you're building a box for these guys to kind of put their entire system, and they're designing to, design team requirements and clinical requirements and things like that. But it's really everybody, it's this prefabricated all-in-one system that sits in the center, and then everybody kind of hooks up into it. That's a big thing because it allows kind of step down flexibility from that standpoint. You're also seeing flexibility from wall panels, and wall panels can come off, and that allows access to gases or power and moving things within the wall system. So you're seeing a lot of more,
interesting,
I'll call it modular and prefabricated.
Oh, yeah.
Modular being you don't necessarily want everything modular because you can't, but not easily rather. But there's modularity and flexibility with the different types of systems that's allowing for more, I'll call it change management moving forward as through the life of the building rather.
Okay.
I mean, I totally agree with Matt that prefab is kind of where everything's going, the more that they can build off-site and bring in and kind of put in place. And I think there's advancements that are happening within that too. There's been prefabbed head walls around forever. At a conference last year, I was looking around, and one of the manufacturers had ways that you could easily just, the facilities guy could take off the panel, route out a hole, and put in another med gas outlet, which
really
increases Matt's flexibility that he's been talking about.
Yeah.
Outside of that, I think BIM and how we model and the level of digital coordination that's happening before these projects ever get built is increasing a lot. The contractors are getting smarter with it. Owners are starting to get a lot smarter with it. So there's going to be a lot of advancements, I think, here shortly in that side of the coordination, which I think will help the process overall.
That's great. Any last words of advice you'd like to recommend for healthcare organizations that are planning new facilities? Kind of a summary of some of the things that we've been talking about. What should they be considering?
I think it really comes down to the stakeholders that they put in the meetings with us. I think those people that they involve not only have to know the current processes, understand how they treat patients using whatever piece of equipment it is, but they also need to be able to look forward. We're going to sit in those meetings. We're going to try to push the clients. We're going to try to say, hey, have you thought of doing it this way? And it really helps when you have users in there that are like, oh, you know what? I hadn't thought of that, but I think we could do that. That could save us some time. So the stakeholders that they put in the meetings, I think, is really one of the crucial things.
It's a good one.
Yeah, I'll echo Joe on the stakeholder side. Like having an integrated owner is really important because we don't own the space at the end. We design it, but it's going to be there, especially with hospitals or like a greenfield hospital, new hospital, it's going to be there after I'm gone.
Right.
So having the clinicians be a part of that process and really letting, for lack of a term, letting them help design their space and knowing what they're going to be doing is really, really important. They have to be comfortable from the layout and design standpoint to be able to work in that facility and make it successful and, help people and heal lives.
This has been fantastic, guys. I've learned so much about medical equipment. So I want to thank you both for joining.
Yeah, thank you.
I'd like to thank Joe and Matt again for joining me on this episode of BSA by Design. You can connect with them on LinkedIn. If you're interested in learning more about BSA and our expertise, we encourage you to visit our website at bsalifestructures.com. There's a link in the show notes to contact us for more information. Be sure to subscribe to BSA by Design on Apple Podcasts, Spotify, and YouTube Music so you don't miss an episode. And we've got more content and project stories that we share on social media, so be sure to follow us on LinkedIn, YouTube, Facebook, Instagram, and X. That's going to do it for this episode. Join us again next time on BSA by Design.